Welcome to Lesson 3B. Today we're looking at a tutorial on how to use the Energy Transformation and Conservation Lab. Now, you're going to begin by clicking the link just below here, which will open up this page for the simulator. Make sure that you click Run Now in green rather than Download or Embed. Run Now is the button you want to click. When you do, this will appear. You will not see any directions in the lab, so it is important to record these directions in your notebook. Record the directions as I'm talking. Maybe even take some screenshots so that when you go to answer the lab questions in the activity, you know you're looking in the correct view. The first thing you need to do to complete this lab is click away from the Intro tab and click on Energy Systems. That's where we will be doing all of our work. We're not looking at the Intro tab at all for this activity. We're looking at Energy Systems. When you do, you'll see a faucet turned off, a turbine, which looks like a wooden wheel, and a water heater. Now, the next thing to do, first we clicked Energy Systems. Next, it's very important to click on Energy Symbols. There's a little checkbox here. This will show us all the forms of energy and how much energy is in the system at any time. You can see that each form has its own color, so you can tell it apart. Immediately, you see red thermal energy in the water. Mechanical energy is gray, electrical, blue, thermal, orangey red, light, yellow, and chemical, green. Pay close attention because if you just glance, it's hard to tell the light green chemical energy from the yellow light energy. But if you put them in context, only one should make sense at a given time. So, now that we're in the Energy Systems tab and we've got the energy symbols and this key showing to tell us what the forms mean, we can try. Let's see if we can get this turbine to turn with different energy sources. First, we'll try the faucet since it's already here. Slide the slider to on and observe. Gray boxes symbolizing mechanical energy are coming out of the faucet. The moving water carries mechanical energy because it's moving. The turbine spins with electrical energy, with mechanical energy, and generates electrical energy as it works. That electrical energy travels through a wire to the heating element under the water heater, creates thermal energy in the water, and as the steam is released into the air, thermal energy leaves with it. You can see the temperature has increased. If you want to start all over, click Reset All. When you do, you'll need to turn energy symbols on again. Now, we saw that the faucet worked with the turbine. Let's see what else works with it. Sunlight with no clouds won't power the turbine. It's just shining on it. It's not going to spin anywhere. What about a tea kettle? Well, just sitting here, the tea kettle's not going to do anything. But if I heat it up, the flame is sending thermal energy into the teapot, and as the steam moves out, it moves with mechanical energy. Yes, the tea kettle on high heat is able to power the turbine and heat up the water. What about the bicycle? Now look, we have a little girl on a bicycle. She's full of chemical energy. Again, make sure you can tell the difference between the green and the yellow. And let's get her pedaling at about half speed. Oh look! The mechanical energy from the wheel of her bike is transferring over to the turbine nicely. The turbine has the mechanical energy it needs to produce electricity. Next, let's check out the other electricity generating device that we have. So we tried all 4 input energy sources with the turbine. Now let's see how they work with the other electricity generating item, which is a solar panel. Bicyclist is pedaling away. It's having no effect on the solar panel. How about our tea kettle? It gives off heat. Will heat work on the solar panel? No, and it's not just because it can't aim. It wouldn't work. How about the sun? Alright, that seems to be working. Now you may not have noticed before, but there's a slider for the sun. This is no clouds, and it's definitely working. What about a medium amount of clouds, about halfway up? You can see now some of the energy is getting reflected away by the clouds and not making it through. But some is still making it through, and we see the electricity still traveling. What about if there are lots of clouds? Well, if there are too many clouds, they will block so much of the sunlight that not enough light energy reaches the solar panel to create any electricity. And do we even need to try the faucet? It's giving off mechanical energy, not light energy, so it's not able to power the solar panel. Finally, the last thing we have not experimented with is the energy output device. So far we have used the hot water heater all along. Now I've set this system back to running faucet, which does work with the turbine, so we see electricity is coming along and it's heating the water. What if we swap out this output device for something else? We can try an old-fashioned incandescent light bulb. Notice, the electrical energy turns onto heat energy on the tungsten wire, which then is released as either light energy or heat energy. We see there's a mix of both. Remember we talked about losing energy as heat in some systems? Here we can see that in action. The yellow light energy, little icons, are what we want, but we're also getting some red, thermal energy, which is being lost. It's not being used to light the situation. You can also try the spiral light bulb. These are called compact fluorescent light bulbs, and they are becoming more and more common. As you can see, they also produce light energy and the occasional little unit of thermal energy. Okay, that's basically how the lab works. You will see very specific directions on how to set it up and questions to answer about specific scenarios in the next assignment. Look below and you have some questions that are things I covered directly with you here. If anything is not working for you, if you were just following along with me but you can't get it open for yourself, let me know right away, because that lab is important and we're going to review that in our next live class. So this is going to be used pretty heavily. If you have any trouble with it, I need to know. Thank you. Have a great day.